Hello, boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary, and thank you guys for tuning in with me. In today's lesson, we are going to examine what happens when we take 6 equal-sized parts and cut them in half. We're going to pick up where we left off. We're also going to play a game that is going to help us understand how you can take fractional parts and join them together to create one whole. In the end of this lesson, we're going to start comparing fractions. We'll start by comparing fractions to 1/2, and then we'll end by ordering fractions from by greatest to least to greatest. Okay, so let's go ahead and begin. In our last lesson, we took 6. We cut each of those 6 in half, and we ended up with 12 parts. We were trying to figure out, well, how do you write a fraction to describe one of those 12 parts? Well, let's examine fractions. We know that the bottom part, or the denominator of the fraction, represents how many parts the whole has been parted into. When you take 6 and you part them in half, you end up with 12 parts. The original whole is no longer parted into 6 parts. It's parted into 12 parts. So your denominator becomes a 12. And if you're looking at just one of those 12 parts, your numerator becomes a 1 because you are examining one of the 12 parts. So if you take a fraction strip or a candy bar and you part it into 12 equal-sized parts by cutting the six parts in half, you end up with 12 twelfths. Okay, in today's lesson, I do have some familiar fractions up here. We introduced the thirds, the 6 and the 12ths in the last lesson, but we're going to include the halves, the thirds, and the fourths in this lesson. So here we go. We have one whole. You can repeat after me. We're going to go over the parts of the fraction. We have 2 halves. We have the thirds, the fourths, the 6th, and the 12th. Another thing I want to do before I forget, we need to record something on our vocabulary wall. For you guys, you can write this down on a separate sheet of paper, or you can write it down in your workspace in the back of your journal where you have your vocabulary. I believe it's like on page 57. Okay. So the vocabulary words that we want to record are the new fractions that we learned from the last lesson. And that's 1/3. And we also want to draw that fraction. And why not draw a fraction circle? Center your dot in the middle of that fraction, of that circle, and then your y. Label each part 1/3. And shade one of those 3 parts. Let's also go ahead and add 1/6. And you'll see the TH in the word 6th, and you'll see it in you'll see my tongue make the sound. So it's 1/6. And that fraction is 1/6. And let's go ahead and also draw that fraction circle, making our infamous y for the thirds, and then cutting each third in half to represent a 6th. And labeling each section of the partition circle 1/6. And shading to show. And last but not least, 1/12. And for this one, we are going to draw the rectangle. And we're going to section the rectangle into thirds. as so. And we're going to part each third in half, creating six. And then we're going to part each sixth in half, creating twelfths. And labeling each part 1/12. Now, boys and girls, we could have done this with the fraction circle, but I know that the pieces would have gotten super skinny, and it would have been almost impossible to write 1/12 in each part. So I'll just do the rectangle, and we'll just shade one of those 12 parts. So go ahead and add that to your vocabulary list, word list, and then you want to find 1/3, 1/6, 1/12 in the back of your glossary and read over the vocabulary definitions. Okay, so let's move this out of the way and get back to our lesson. So we're going to begin with the game Cover Up. Uncover, sorry. Okay. All right, uncover. So here's my dice. I have the blue dice this time. One side has 1/12. That's why the 12s are up here. One side has 1/3. You have 1/6, and you have 1/4. And I believe some of these are on here twice, and you also have half. So we roll the dice, and once we roll the dice, we are going to, we're probably going to play it a little different. We're going to play Cover Up. We're going to use the pieces to cover up the hole. And then we're also going to write an equation. Now, usually when we play this game, we're going to play Uncover, not Cover Up. Usually when we play this game, we're supposed to take the fraction strips and cover it on top of the hole and see how many it takes to actually cover the hole up. And we write an equation to match to show which fractional parts can be added together to create one whole. But it's difficult to see the hole if I cover it up. So I'm just going to take the fraction strips and I'll put it underneath, and we'll try to create a train. We will create a train to match the length of one hole. So let's see which fraction strip we will use first. 1/6. Okay. Let's do another one. And we'll play about 2 rounds of this game. 1/12. Have we created a train yet that is the length of the hole? Not yet. So far, we're adding which 2 fractions together to make a whole? 1/6 and 1/12. Another 1/12. Another 1/12. We're getting there. In order to create a train that's the same length as the one hole, we'd have to get our train all the way out to the full length of the hole. Half. Whoa, look how big that half piece is. The half piece is pretty large. It filled in a good amount of space underneath this one hole. Now we do need this section right here in order to create the train that matches the one hole. So let's take a look at our fraction strips. Which fraction strip do you think will fit right here and will finish the train without adding on too much? Because you know, if I roll one that's too large, I can't use that one. So I know I don't want another 1/2 because it's gonna stick all the way out on my wall. I probably would want a smaller piece. Which piece do you think would fit perfectly here? Think about the smallest piece that we have on the board. Maybe another 1/12. Let's see. I have a 1/6. Let's see if it will go. Oh, no, it's not going to go. I can tell it's not going to go because it won't even slide up right here. So if you were playing with your partner and you rolled a piece that would be too big, you would lose a turn. Another 1/6 piece. It's not going to fit. We already know that. Let's try the 1/12. Perfecto. So now that we've created a train that is equivalent to 1 whole, let's go ahead and write that equation. So we have 1/6 plus 1/12 plus 1/12 plus 1/12 plus 1/2 plus 1/12 is equivalent to 1. Now, in our previous lessons, we have learned ways to shorten the equations. So I am just going to shuffle some of these around. If I wipe off some of this, forgive me. Okay. And we know that this equation was pretty long, even though some of it has wiped off. But we're going to combine the 12. So we have 1/6 plus 1/12, 2/12, 3/12, 4/12 plus half equals 1. Remember when we change the order of add-ins? Add-ins are numbers that you're adding together. If you change the order of those fractions or numbers, it doesn't change the total sum. It just changes the order, but you'll still get 1. So 1/6 plus 4/12 plus 1/2 is equal to 1. All right. Do we have time to play another round of this? Let's see. Let's play another round of cover up. Oh, let's keep that there. It was 1/6 plus 4/12 plus 1/2 equals 1. Okay, so the first number that I rolled is 1/6. Those 1/6 are pretty popular. Just trying to figure out how many times it's on this ice. It just looks like it's on here just once. 1/12. Another 1/12. Which is greater in size, a 1/6 piece or a 1/12 piece? 1/6. I bet you're waiting for me to roll a half again because you saw how big it was. Another 1/12. Another 1/12. Another 1/12. Are you counting these 1/12s? Another 1/12. Man, we have a lot of 1/12 pieces here. One-fourth. Whoa. That 1/4 piece is not as big as the half, but it takes up a lot of space. I can tell that the 1/4 is larger than the 1/12. And it's also larger than the 1/6 piece. Okay, so we're back to the point where we were before, where we have a small marginal space here. What size piece do you think we need to roll in order to fill that space? Maybe a 1/12. Come on, 1/12, don't let me down. And you let me down. I know a 1/4 piece is not going to fit there because it's too large. Let's try again. You think that piece is going to fit there? Absolutely not. Look at this little space. That thing is too large. So we need to understand how big a half-size piece is. The 1/6, will it fit? Nope. It's not as big as a 1/4 piece, but it's bigger than a 1/12 piece. And we got our 1/12. Yowza. That's a lot. All right, we have put enough strips up here to match the length of 1 whole. We're going to write that equation as, we'll drop it down some, 1/6 plus, I'm not writing all of that. Let's go ahead and shorten this because that's a lot of 12s. So we will rearrange our 12 pieces and we'll count them. 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s. 1 6 plus 7 12ths plus 1 4th is equivalent to the size of one whole. So that's 1 6 plus 7 12ths plus 1 4th is equivalent to one whole. Okay. Now, you guys did a wonderful job playing this game. I like playing cover up and uncover because it helps me to think about the different sizes of the different fractional strips. As I'm thinking to myself, oh, I need a 1/12 piece. I need a smaller piece. I'm thinking about how small a 1/12 size is compared to a half. And when I put the half piece up here, it took up a lot of space. So I'm like, whoa, that 1/2 piece is pretty large. All right, moving on to another part of the lesson. We are going to add more fractional parts, fraction strips, because at this point we're getting ready to review all that we have learned. So I'm going to go ahead and add the eighths, and we're getting ready to compare fractions to 1/2. Do you remember how many eighths are equal to one whole? 8. If you take a candy bar and cut it in half, you'll get 2 parts. You take both parts and cut those in half, you'll get 4 parts. If you take the 4 parts and you cut them in half, you will get 8 parts. And you need all 8 of those parts to make up your whole. So we're just making room here for the 16ths. And at this point, boys and girls, you need to get all of your fraction strips out. You should have all of the fraction strips that I have here. When all of the fraction strips are out, the board does tend to get a little bit crowded. But the one thing that I want you guys to pay attention to is how all of these fraction strips are the same length as one whole. So all of the 12ths are one whole. All of the 16ths will match the length of the blue one whole strip. So at this point, we need to focus on how many of those pieces does it take to match the size of the one whole. How many halves do I need to match the size of one whole? 2 halves. 2 halves are equal to 1. What about my thirds? How many thirds are equivalent to one whole? 3 thirds. Good job. What about the fourths? How many fourths are equivalent to one whole? 4. You need all 4 of the fourths to match the length of the one whole part. What about the 6th? You need all 6 of them. 8ths. 8 eighths is equivalent to one whole. 12ths. How many 12ths do you need to match the length of one whole? You need all 12 of them. 12 twelfths. And 16ths. How many 16ths are equivalent to one whole? All 16 of them. Okay, so let's take a look at half. We're going to make a chart comparing how many of each fraction is the same length as half, how many are greater than, let me fix that, How many are equal to half? How many are greater than half? And how many are less than half? So we'll definitely fill the center column because we want to know how many thirds are equal to half. How many fourths, and how many of each one is equivalent to half. So let's go ahead and start with half. How many of these red pieces do you think I'll need to match the size of the half? Half is equivalent to half. Whoops, I'm having some technical difficulties here trying to get this strip off. Well, to save on time, we're going to use our imaginary line. So we know that half is equivalent to half. Now, if I come over here and I go starting at half, this is my imaginary line here, and I'm going to drive it all the way down here. So my imaginary line for half starts here, and it goes all the way down to here. And my other half line starts over here. So this, from here to here, represents half. So let's take a look at all the fractions that match the size of half. I know that 1/2 is equivalent to half. Let's take a look at the thirds. In this window, I have 1/3 and a part of a 2/3. So if I was to take 2/3, they come out a little bit farther. So 2 of the third size pieces would actually be greater than my half. Because I can't split that third in half. Not right now I can, but we're not going to do it right now. So let's continue to drive our eyes down our imaginary line to the fourths. Do we have some fourths that are equivalent to half? Yes, we have 2 of the fourths that are equivalent to half. And we're going to drive down to the 6th. Do we have some 6 that are evenly equal to half? Because the thirds weren't evenly equal to half. I would have had to cut one of the thirds in half. And then when I cut it in half, it becomes a 6th. So let's take a look at the 6. How many 6 do we have that are equivalent to half? 3 of the 6 are equivalent to half. What about the 8ths? Do we have an even amount of 8ths that's equal to half? 1/8, 2/8, 3/8, 4/8. Driving down my imaginary lane. 4 of the 8ths are equivalent to half. Keep driving down my imaginary lane of half. What about the 12ths? I can see where the line goes evenly through the 12ths without cutting any of them in half like the thirds. So let's see how many 12ths are equivalent to half. 1/12, 2/12, 3/12, 4/12, 5/12, 6. 6/12 are equivalent to half. And let's drive down this imaginary lane. Oh, look at that. We got an even cut for the 16ths. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16. 8/16 are also equivalent to half. So right here, my friends, we know that half of the total number of fractions in each whole are also equal to our half strip. Just think about it. When we made our fourths, we took the 2 parts and we cut them in half. That's how we got the fourths. In order to make the 8ths, we took those 4 parts and we cut those in half. So we were able to break those in half to create more. When we made the thirds, we couldn't take the whole and cut it in half. That might be why none of the thirds are equal to half. But we were able to take the thirds and cut them into half to make 6. And we were able to take the 6 and cut those in half and make 12s. So we can use half as a tool for measuring which fractions are greater and which fractions are less. Okay, now we're going to get into some comparing fractions. You guys did an excellent job here. We're going to use our fraction strips to help us figure out how to put these fractions in order from least to greatest. So the first two fractions at that is 1/6 and half. So I have my half here. I want to know which is greater, 1/6 or half. Well, let's have a look, shall we? Let's take out, well, what do you predict? Which do you predict is going to be greater, the 1/6 or the half? Yeah, I've had, whoops, I put 1/12. I've had enough run-ins with 1/6 and half to figure out which would be larger. The half is greater. Well, let's go back to the previous lesson. I would need 3/6 to match the size of a half. So if I don't have 3 of them, I have a smaller amount. 1/6 is less than half. So if I want to put these two fractions in order from least to greatest, I would put 1/6 and then half, because it's from smallest to biggest. Now let's throw in another fraction. Let's throw in 2/3. Well, I already know that the 1/6 is smaller than the half. So now I want to compare how big is 2/3 compared to a half. Wait a minute. We just did a lesson with those thirds and the halves, and we discovered that there were no thirds that were equal to the half size. In fact, just 2 of those thirds were larger than the half. The half is larger than the 1/6. But the 2/3 is larger than the half. So the gator doesn't want to eat the 1/6 because it's smaller than the 1/2. He wants to eat the 1/2. But when the 2/3 cookie came along, he no longer wanted to eat that. He wanted to eat the 2/3. So the smallest would be 1/6, but 1/2 is greater in size than 1/6. And then came 2/3, which is greater than 1/2. Are you guys getting this? Of course you are. Well, I am out of time today. I want you guys to continue to compare fractions. Use your fraction tiles. You guys can work on putting fractions in order on page 54 in your workspace workbook. When in doubt, fraction strips out. Use your fraction strips because it's all about size here, guys. You want to know which is greater in size. And if this one is greater in size than that one, then that one is less in size. 1/6 is less than 1/2, and 1/2 is less than 2/3. You know what else that means? 1/6 is less than 2/3. Because if this one is bigger than me, and that one is bigger than him, then he's also bigger than me. All right, boys and girls. Thank you guys for tuning in with me. It has always been my pleasure. And I will see you guys next time.